I collect data. If I'm doing Agile team, it's the Scrum Master's job to collect the data. If it's waterfall, it's the test lead's job to collect the data. But I want to collect the data after a task is done, not before the task is done, after the task is done. And the data I'm going to collect is, I'm going to show it in a minute. So I'm going to collect data every time you do a task. This estimation technique only works if it's the same team. I have a customer who used this technique with the same team for 10 years, over 10 years. And it's a big company. It's IBM doing financial software for one of Canada's major insurance companies. So it's not just a small team in a corner somewhere. And they used it very rigorously, this simple method, very rigorously, over that period of time. And when I trained them in it, I did it with them in small workshops where we took real projects and we looked at the real data to try to estimate them. So we started with real stuff. And they kept collecting data forever, same team. They kept always, whenever they finished a task, they collected the data. It was very easy to collect it. The same relationship between skills and work. This estimation technique only works if the relationship between the skills of the tester and the work they do is similar. If it changes dramatically, let's say you're doing manual testing once and then automated testing with another tool, the next one, your estimate's not going to be effective. You'll have to start again because the relationship between skills and work, and that's true with any estimation technique, not just mine. It's just, I want to highlight that. So after the task, what we capture is this. So we capture, first of all, I like to capture examples. So this is an example of a task. And I try to remember I said 9 different stories without any information? I like to collect 9 different examples, real examples, that real testers really tested on real projects. That they know, that if I said, this is Project Fisbin, you know in your heart what it is. It's not abstract, it's very real. So we have the example. For every story, or every task, I collect 2 dimensions. Size, how big is it? For a testing project, usually, it's how many conditions do we have to consider? How many factors? More factors, bigger. Fewer factors, smaller. It's not the size of the software. This is not a function point analysis, right? We're talking about collecting, testing, task data. So, size. Then there's complexity. Complexity has to do with the technical work that was done to create what you're testing. Was it easy? Was it hard? Was it complicated? I like to break it down to three factors for each. So for size, small, medium, large. For complexity, easy, typical, hard. So I try to break it down into 3. My record, though, I have customers who do up to 5. But personally, 3 is my magic number. I think 3 works really well. We capture the actual effort. So when you finish a task, you'll tell me, well, that was a small task with a normal complexity, and it took us 3 sessions. I have the data. I have the size, the complexity, and the actual effort. That's all we do. And you collect it when it's finished. So of course the tester knows they just finished it. It's not abstract. It's not from a timesheet. It's a collection when a task is finished. And I put it in a simple spreadsheet. Then when I do my estimate, I use that data to make the new estimate. And as I said to you before, I use different hour sessions. This is my favorite, but I can use hours too. The example is this one. Hello, example, where are you? This is an example. Click. Okay. Please apologize for. So, whenever this spreadsheet, electronic copy, if you want, send me the email, get the link to it. This is the magic spreadsheet here. Very simple. Very simple. When you finish a task, you collect the size, complexity, and effort in whatever units you like. If it's effort in hours, collect hours. I collect sessions, collect whatever it is. So you have a task and you said, you just collect, you don't even collect the name of it. You don't need to know the name of it, just what was the size? Was it small, medium, large? What was the complexity and what was the actual effort? So when you collect that, After each task is finished, you collect the data, put it in a spreadsheet like this. This is just a list of all sorts of tasks with actual data. Now, for a new effort estimate, what I will do is when a new task comes up, before we start the task, I will ask, what's the size and complexity? I still have to estimate, but I'm not estimating how many hours work. I'm looking at it, and I'm saying, what's the size? And what's the complexity? And then I can pull out this number here. If it's a small simple, it's 1.7. If it's a large complex, it's 8.8. And that's how many sessions it takes based on the PERT model from real past data in a trivial spreadsheet that collects 3 pieces of data whenever you finish a task by a Scrum Master. It's very easy. I'm trying to emphasize the not fancy calculations and calculus here. You need a spreadsheet. It has to fit your culture a little bit. Here's my definitions that we used. This is close, very, very close to the definitions used at the group, the financial company in Canada. So for size, we had small, medium, large. Small, this is again a testing, like a testing task. So one test objective could have many tasks. Each task, you can describe what you want to learn, right? So we know what we want to learn, but it's not generally saying, I'm going to test a feature. It's going to be more specific than that. So for small, we said very few variables to consider. So I figured under 5. There's only 5 or less factors. That's small. For medium, we have a nominal number between, let's say, 5 and 10 factors. And these are factors you have to study. You have to change them, you have to observe them, you have to manipulate them, you have to do the domain analysis and mind maps and whatever, real work with those factors. Don't just make up, of course there's 1,000 factors. What are the 10 that matter? What are the ones we care about? And large would be anything greater than 10, for example. So I have 3, so small, medium, large. I know I need XXXL for my, sure, because I'm big. In Canada, that's a joke. Everyone laughs when I say that. Malaysia, they don't laugh. They see a fat guy who just makes fun of his. We call it self-deprecating humor. It's a Canadian thing. Okay, anyway. Complexity. Simple. Simple. No change to program logic. Maybe there's a change to data. Maybe there's a change to the HTML. Maybe there's a change, but the logic doesn't change. Simple, no change to logic. We can do backward comparison, old versus new, right? So no change to logic. Typical one. We have changes to the logic. We're not just changing the menu, we're changing the calculation, we're changing the algorithm. And complex, new logic, refactoring, new design, new algorithm, new things. So I'm giving you a simple scale for complexity. Of course, you have to make a scale that meets your culture, your team. A simple scale for size. You pick one, hopefully related to factors for your team. Collect the data, try it for a couple of weeks. It does not take long. After a while, suddenly people get very easy. When they're estimating, they'll say, well, I have 5 test objectives. That breaks down to about 20 tasks. This, those are small ones. This, these are complicated ones. We got to talk to the programmer about the complexity because it varies. I mean, we need to talk to technical people about the change, but we can. And once you got that, pump it through, and it'll give you the calculation, and it's basically here on this spreadsheet here. So the actual calculation for the estimate is that 4 times K5 plus L, 5 plus M5 divided by 6. That's the PERT estimation. That's it, that's all. It's simple, it's practical, over 10 years of use. It makes things real, it gives you good estimates, as long as you don't keep changing your teams and everything. What's missing from this method, again, send me the email, we'll give you the electronic copies of all this stuff. What's missing from the method is, so what is not there, we don't have capital costs, right? There's no cost of tools and equipment, it's just not there. All we're estimating is the work, the task. It doesn't include depreciation costs or accounting costs. So by the way, I like to use sessions because you can't trick a session for me. If you say days, you might work 8 hours, 12 hours a day. So you have to pick your units carefully. It doesn't include fixed costs, contractors, fixed costs, things like that, or training costs. and things like that. So there's many factors that are not in the estimate, but it is a good estimate for the actual work breakdown. And that's all I wanted to say today. So, thank you. Not bad for the time. Okay. And don't miss the keynote. If you want to still talk to me, I'm going to stay here. Please send me the emails, and I will see you at the rest of the conference.
I cannot look at a cookbook. I couldn't take thermodynamics anymore without pictures, because I have to learn with pictures. So if you're a visual learner, what you'll do is you'll look up, and if you look left of center, you're more dominantly right-brained. If you look slightly right of center, you're more dominantly left-brained. So anybody who's not a visual learner is thinking I'm crazy right now, because you're probably either an audio learner or a kinesthetic learner. So we visual learners need pictures, we need clip art. If you're an audio learner, then what you're going to do is you set it to yourself. You're going, okay, 34 times 56 is approximately 30 times 50. You're saying it. You're the type of person who, if there's a click in the car, as you're driving, something clicks, you're going, okay, what is that? What is that? Stop that. Stop. Because you're an audio learner, and that's how you learn, through audio and through analytical stuff. You don't like any clip art. I did a co-presentation with an audio learner. He said, Carol, if you get rid of that clip art, do you know how many more words I could put on that page? And I said, oh my gosh, you can't do that. Now, some of you are still going, okay, that doesn't make any sense. And in a lot of my classes, people will go like this. They're like, I say, multiply that in your head, and they write it down. Because you're a kinesthetic learner. You need to interact and talk about things. So Rational Rose and IBM, when they came out with the object-oriented and object models, they stumbled into using 3 learning styles. And if you don't make sure that every presentation you do varies your voice, if I stood here and said, okay, this is you're going to learn a lot in the next hour, and audio learners would be going crazy. They'd be going, I gotta get out of here, I can't do this. Visual learners need to see pictures, and kinesthetic learners need to talk about it. The reason I mention that is in one of the classes I did a project management class for clinicians at Sanofi Pasteur. They look after doing clinical trials. They bring people in, they talk to them, they get them to do tests and test the products. One of the people in my class said the best thing they learned in the entire class, a whole day in project management, was those 3 learning styles. Because she said she had been trying to teach her whole group something for 3 months. She said, I kept telling them and nobody got it. She said, and then somebody came in from outside and said, well, let me try it. And they explained it in a different way using audio learning, because she was a visual learner, because we present in the way we're accustomed to, in the way that is natural to us. So she was missing 2/3 of our audience because she was teaching only from a visual point of view. So if you're a visual learner, you're going to use clip art, and you're going to do things the way that you learn best, and you're going to miss 2/3. So you need to know, if you're going to talk to your company about function points or anything new, if you're an audio learner, you got to use pictures. If you're a kinesthetic learner, you've got to vary your voice. You've got to use all 3 learning styles. So how many in here would say you're a visual learner? Okay. How many people would say you're an audio learner? Okay, less. And how many would say you're a kinesthetic learner, that you need to interact? Okay. So we've got a mixture here. So if I just was really monotone and read all my slides, we'd lose some people. And if I had all words, we'd lose other people. And we'll have some interaction so that I don't lose the 3rd type. But what I did here is, oftentimes when you're on a project, you feel like you're the only one. You're kind of waving this I surrender flag, and especially if you're a tester, and they cut testing time and you're at the very end, you just feel like, I should just throw in the towel. Do you ever feel like that? Well, Software development challenge, what do you think the top 3 software development challenges are? What do you think? What would be one?
Scope creep.
Scope creep. Okay, what else?
Deadline.
Deadlines.
Human factor.
Pardon me?
Human factor.
Human factors. Oh yeah, we're dealing with, somebody said to me one time, you know what? Software development would be so much easier if we didn't have to deal with those users. That's right. Well, according to Benetton, Glass, Larry Putnam, Tom DeMarco, many other people, it's requirements, it's estimation, and it's change management. Those are the top 3 top 3 challenges. So let's take a look at what happens with requirements. With requirements, we have a problem of, are they complete? Are they expressed in business terms? Because if our user community is expressing the requirements, they might say them one way and we might mean something completely different. So are they expressed in business terms? Are we prioritizing them? How many of you are doing agile development at all? Not yet? Well, when agile development comes in, that's going to be very interesting because it's a totally different way of looking at things, where we don't have requirements to begin with. They start with user stories, which is what you put on a 3x5 index card, a small index card, just very little bits. And then you have to prioritize constantly and pull something off the pile and say we're going to work on it for 2-week sprints with our customers. But when you're taking a look at all your requirements, which ones are the highest priority? Because you're probably not going to be able to deliver all of them. But how do you prioritize them? Are they understood? Now, every requirement should be SMART. And SMART is an acronym which means strategic, measurable, actionable, realistic, and time-bounded. So there needs to actually be a time associated with it. Have we documented the assumptions? I was on a software development project one time working with court reporters in a court system. So we had this word CASE, C-A-S-E, which to the police, a case was all of the charges that were brought against an individual associated with one incident. So say you've got a massive party. You might have 50 arrests, a bunch of different charges and things like that. To a policeman, that was a case. To a lawyer, a case meant something completely different. To a court reporter, that word case meant something completely different. So we had to document our assumptions so that we made sure that we had that. And what about the requirement size? Does that make a difference? Yeah. Well, when we get into estimation, what are our challenges? Well, we've got multiple models, depending on whether you've got hardware involved in a project, whether you've got software, whether there's infrastructure, all the different types of projects. We've got complex weighted inputs, because in parametric estimating, it is not a linear association between size and effort. It would be nice if I could say size times a magic number equals effort. That would be great, but it doesn't happen that way. So we've got complex weighted inputs, including the language and the methodology and hardware, risk factors, the subject matter, the domain, the skills, the experience. Size is pretty important, isn't it? Platforms, and having a historical base of similar projects to what I'm trying to estimate, that's going to be important. When we get into change management, change is absolutely inevitable, right? The only time you don't have change on a project is if it's a one-day project and you had the requirements yesterday and I might be able to do them today. Otherwise, you're going to have change. Change is a natural fact of life. When you have those changes, we have to do trade-offs, correct? So we're not going to be able to fit in the same amount of scope into the same cost, the same effort model. If the scope increases, what happens? If I increase my scope, normally your cost is going to go up. Normally your schedule's gonna go up. What's the customer definition of quality? How good does this project have, or how good does this product have to be? And does that ever change? Your assumptions when you first get into a project and you do an estimate, what happens? Does the quality ever have to go up from what you thought it was? What about corrections versus changes? Is that ever an issue? Especially in fixed price contracts where you end up with, you've signed up for something, you've said, okay, we will deliver you this piece of software within this time frame and for this cost. And so in comes the supplier, or the supplier says, this is a change to the requirements. And what does the user say? No, that's a clarification. I always meant it to be this way. So is it a change or is it a correction? And then we end up with something called rework spirals. Do you know what that is? Rework is when you start working on something, and what happens when you're partway through? You have to do it over again. Rework, and this is a number that just always astounds me. Rework accounts in some of the governmental departments in the United States for 60% of work effort. 60% of software development work effort. That means on Monday, Tuesday, we go in and we do really great work. And what do we do Wednesday, Thursday, and Friday? We redo it. That's huge. So that means every single week, if it's 40% is not rework and 60% is rework, Monday and Tuesday we do great work. Wednesday, Thursday, Friday, we're redoing that. That's huge. And what about the size of changes? Does that make a difference on your projects? Yeah, that's a challenge. So when we get into software measurement, these are some major components. Consistency through repeatability. You want to make sure that you measure the same way going forward, that you measure every project the same way. You measure using the same way, the same rules. History is a much better predictor of future behavior than theoretical models. Now they also say results. Well, we need to be able to do something different if we want to have different results. The status quo. Now, one of the biggest things you're going to find when you get into measurement is how bad you are doing today. And there's some basic building blocks that we need for doing any project. We need to know size. We need to know consistent effort. Now, effort is an issue, right? Why is effort